Good morning, guys. We are looking at properties of parallel lines today. I know that some of you have been checking on me to make sure I was okay because I haven't posted anything in a couple of days, and I do apologize for that. I have been pulled in about 1,000 different directions, but I'm trying to get things caught up. I have a couple of videos made in advance now, ready to go, and this is going to be the first of those videos. We are doing a review first. First thing we're looking at is the circle, or the symbol for that indicates congruency. And I'm going to start at the end of the list because the first one is the congruency symbol. But that third symbol right here is the symbol for parallel. And then, of course, your middle symbol there is for equals or equality. And then our first symbol is the congruency symbol. For 2, 3, and 4, we're looking at indicating whether or not an angle is acute, obtuse, or right. Remember, an acute angle is less than 90, a obtuse angle is greater than 90, and a right angle is exactly 90. So for number 2, the angle is 125 degrees, which is greater than 90. So this will be an obtuse angle. For number 3, the little box here in the corner indicates that is a 90-degree angle, so it must be right. And then for number 4, it's 72 degrees, which is less than 90, so it will be an acute angle. That should be a pretty simple review and stuff that you are already pretty strong with prior to even taking this class. The vocabulary builder. Really, the only thing we're interested in today is the geometric definition of the word interior, and that is going to be the region that is bounded between, in this case, 2 lines. It can be bounded between multiple lines, but the interior is going to be between these 2 lines for the purposes of our discussion right now. Using the diagram on the right for 5 and 6, it says that the interior of the circle contains the point A, B, or C. The interior of the circle is everything that's inside the circle, and we can clearly see that contains the point A. So we can eliminate B and C. Then for number 6, it says the interior of the angle, so that's between the 2 lines, contains the point A, B, or C. Well, A is the vertex. It's not within the interior of that angle. B is the only point that is in the interior, and C actually happens to lie on the line, or on one of the rays that makes up the angle. Number 7, underline the correct word to complete the sentence. The end point of an angle is called its vertex, and that says underline and I circled. So the end point of an angle is called its vertex. The other 2 possible names on number 8 that we can label angle ABC, there's actually 3. 2 of them that we're going to come up with. The first one we can just simply name it angle 1, as indicated by the number 1 there in the vertex. The other possibility is simply angle B. The third possibility could be angle CBA, just taking the original named angle and reversing the orientation of it. So it's angle CBA. In either case, the vertex in both of those scenarios is at B. We are now going to look at postulate 3.1 and theorems 3.1, 3.2, and 3.3. And all 4 of these scenarios are based off this first indicator here, that if a transversal intersects 2 parallel lines, then for postulate 3.1, we have that the corresponding angles are congruent. For theorem 3.1, given that scenario that a transversal intersects 2 parallel lines, then we know that alternate interior angles are congruent. Theorem 3.2 tells us that same side interior angles are supplementary. That means they add up to 180 degrees. And then theorem 3.3, alternate exterior angles are congruent. So let me just indicate under here that supplementary is 180 degrees. Complementary, they would be 90 degrees. So same side interior angles would form a line. Using the organizer over here to the right, or the graphic that's here to the right, we want to answer questions 9, 10, and 11. Use the graphic organizer and the diagram to find each congruent angle. So based upon theorem 3.2, which says that corresponding angles are congruent, then we know that based on postulate 3.1, sorry, that should actually say theorem 3.2. I don't know why that says 3.1. Theorem 3.2, angle 3 is right here, and based on theorem 3.2, which says that corresponding angles are congruent, the angle that corresponds to angle 3 is angle 1. For number 10, it says theorem 3.1. Theorem 3.1 says that alternate interior angles are congruent. So the angle that is alternate and interior to angle 3 is angle 7. And then finally, theorem 3.3, it tells us that alternate exterior angles are congruent. So we're looking for an angle that is alternate and exterior to angle 1. So alternate means it's on the other side of the transversal, and it is exterior, so that would be angle 5. All right, problem number 1. So here's our first problem. We're going to start applying these things. Problem number 1, we are given this figure. It has the 8 angles indicated. One angle is indicated to be 55 degrees. We want to write a justification for each statement on number 12, and we're first told that the measure of angle 7 is 55. So that here's angle 7, and we're told that it's 55 degrees. Well, that comes from the corresponding angles postulate. For the measure of angle 5 being equal to the measure of angle 7. So here is angle 5 and angle 7. That is the vertical angles. We talked about that previously. That's vertical angles theorem. And then the measure of angle 5 is 55 degrees. That comes from the transitive property of equality. We've already indicated that the measure of angle 7 is 55 degrees in this first step. In the second step, we said that the measure of angle 5 is equal to the measure of angle 7. So therefore, by the transitive property of equality, we can see that these angles are equal. Right, transitive property of equality. I keep zooming in too much. All right. For problem number 2, it's proving an angle relationship. So we're given that A is parallel to B. That's given to us. We want to prove that angle 1 is congruent to angle 7. Now we can look at the figure, and we already know just from the theorems that we've looked at, these are alternate exterior angles, so they must be congruent. But we want to think through the process that leads us to that conclusion other than just blindly trusting this theorem that tells us that these two angles are congruent. So in the first column here, we're going to put down our statements. To the right, we're already given the reasons. So the reason for number 1 is that it is given. So what's given to us is that A is parallel to B. So since that is already completed for us, now we can move on to step 2. Step 2, the reason is if lines are parallel, then corresponding angles are congruent. So let's base this off of angle 1 must be congruent to angle 5. So these are corresponding angles, 1 and 5. For number 3, it says congruent angles have equal measure. Well, we're going to base that off of the second step. So the measure of angle 1 is equal to the measure of angle 5. Number 4, vertical angles are congruent. Angle 5 is vertical to angle 7. So now we have that angle 5 is congruent to angle 7. Congruent angles have equal measure, so now we again can take our previous statement and just convert it to angle measures. So the measure of angle 5 is equal to the measure of angle 7. And then for number 6, it's the transitive property of congruency. We've proven that angle 1 is equal to angle 5. We've also shown that angle 5 is equal to angle 7. So therefore, angle 1 must also be equal to the measure of angle 7. And therefore, we can say that angle 1 is congruent to angle 7. So that's kind of a very basic proof. But again, like I said, we wanted to walk through the steps just so that we're not blindly assuming that these theorems that we're given are 100% correct. That's going to take us into problem number 3, where it says find the measure of angle 1, justify your answer. There's 2 sets of parallel lines. Each parallel line also acts as a transversal. Because we have 2 pairs of parallel lines, anytime a line crosses a set of parallel lines, it becomes a transversal. And now we're going to justify, in this case, now we're given the statements. We want to give the reasons why those statements are true. So the first one we're given is that the measure of angle 1 is congruent to the measure of angle 4. That is because of the zoom feature on my computer. There we go. All right, and I did it again. Okay, so that is the alternate, let me bring that back into view, alternate interior angles theorem. For number 2, it says that the measure of angle 1 is equal to the measure of angle 4. Well, that's just because congruent angles have the same measure. So congruent angles, same measure. Number 3, it says angle 4 and angle 6 are supplementary. That's the linear pairs postulate. Angle 4 and angle 6 appear right here. So that is the linear pairs postulate. Any 2 angles that appear on a line together that form that line are supplementary. They equal 180 degrees. So linear pairs postulate. Number 4, the measure of angle 4 plus the measure of angle 6 is equal to 180. Well, that's the definition of supplementary angles. Supplementary angles have to be 180 degrees. The measure of angle 1 plus the measure of angle 6 is 180. That's from the transitive property of equality. And we know that because we've shown that the measure of angle 1 is equal to the measure of angle 4 here in step 2. And then in step 4, we said that the measure of angle 4 plus the measure of angle 6 is equal to 180. Well, if the measure of angle 1 is equal to the measure of angle 4, we can substitute in angle 1 for angle 4 and use them interchangeably. So that's the transitive property of equality. For step number 6, it says that the measure of angle 5 is 105. That is because corresponding angles have the same measure. For step 7, it says the measure of angle 6 is 105. Alternate interior angles have the same measure. Then finally for step 8, or sorry, not finally, but almost finally, step 8, the measure of angle 1 plus 105 is equal to 180. We're just substituting into the 5th statement because we have established that angle 6 is 105 degrees. So we can now say that we'll just use substitution. We substituted that value into step 5. And then finally we have the measure of angle 1 is equal to 75. We've subtracted 105 from both sides in this case. That is from the subtraction property of equality. And that tells us that angle 1 is 75 degrees. For problem number 4, it says use algebra to find the angle measure. In the figure at the right, what are the values of x and y? The bases of the trapezoid, so here's base 1 and here's base 2, they are parallel to one another. Using the same side interior angles theorem to complete each statement. 2x plus some other angle is going to be equal to 180 degrees. The same side interior angles theorem tells us that if 2 angles are on the same side of a transversal and they are on the interior of the parallel lines, then those 2 angles are congruent. So let's imagine for a minute if we just looked at these lines here that form the sides of the trapezoid. This could be a transversal. This could be a second transversal, and then we obviously have these two lines that are parallel. So now we have formed two interior angle pairs that are same side. So it's these two and these two. So if I add the two angles in red, they should equal 180 degrees. So we have 2x plus x minus 12. And then on the right-hand side, we have 3y plus y plus 20 equals 180 degrees. Now let's just simplify those. 2x plus x is 3x, minus 12 is equal to 180. We would subtract 180 from, or sorry, add 180 or 12 to both sides, and we get 3x is equal to 192. Divide both sides by 3, and we get x is equal to 64. For the second statement on the right, 3y plus y is 4y. So 4y plus 20 is equal to 180. Subtract 20 from both sides. So 4y is equal to 140. Or, sorry, 120, 160. I subtracted 40 and I was thinking 140 in my head. I don't know why. Divide both sides by 4 and you get y is equal to 40. I was jumping ahead of myself. So we have our two values for x and y. X is 64, y is 40. And our lesson check here at the end. We're given the diagram at the right. Angle 1 and angle 8 are supplementary, so that means they're 180 degrees. What is a good name for this pair of angles? The best name for lines A and B is that they are parallel. We can see that just from the diagram. So from the two angles given, 1 and 8, they are the same side of the transversal. Here's angle 8, here's angle 1. They're on the same side of the transversal. They are both outside of the interior, so that means they are exterior. And we can now justify that these two are same side exterior angles. All right. Again, I apologize that things have gone kind of haywire the past, this week and then the couple of days towards the end of last week. I'm hoping that these meetings that we get surprised with will kind of die down a little bit, and we can focus on the content for this class. I hope everybody's doing well. Please contact me with questions. And don't forget, if you signed up to meet with me today, those meetings will start at 12:30 and go until a little bit after 2. So far, everybody has shown up for all the meetings this week, and I appreciate that. And I look forward to seeing the rest of you as the week goes on. Everybody take care.